Hey, John Wiley here with SDS. Welcome to our series on how to keep your EasyBender calibrated. Now listen, over the 20 years that EasyBenders have been sold, there's different models that are out there. You may have the classic model, which is the first series that was introduced, and we sold hundreds of those. And then we had to move toward the turbo. Now you may have a turbo model, and those turbo models did 2-point and 3-point, or two only or three only. Or you may have the S1, the newer model that we currently have. This sequence of calibration videos is going to be able to handle any of those models, because how you calibrate, the basics of keeping a machine calibrated really are the same in their core across the different models over the years. The model has improved over the years with different functionality, but how you calibrate remains the same. So rest assured that what I'm going to show you is usable regardless of which model that you have. Before we get started into the specifics of how to calibrate, I wanted to have a quick visit on why is it important to calibrate. Now that may seem like a silly question, why is it important to calibrate? But I want to get into the specifics. Why is it important to calibrate an EasyBender? Because we know that any piece of equipment, whether it's a laser or any piece of equipment you've got in the die shop, from hand tools to automated equipment, they just run better when they're calibrated, sharpened, and good to go. You know, keeping an EasyBender calibrated is important because of how accurate they can be. As I go around the country visiting different die shops, I'll walk into a shop and they'll make some broad statement about the bender that, well, that bender, and they'll point to an EasyBender, it won't do this or it won't do that, or it always does this, and it'll usually be some deficiency they'll tell me about. Now, I know what these machines are capable of doing, so one of two things is going on. Either there could be a worn out component because it's an older model that could be fixed easily, or it might be, and it usually is, because I'll ask, well, when was the last time you calibrated? And the statement will be, well, we're not sure, or a year ago, or this or that. And then that tells me that there's several important data points that have drifted, and so your efficiency on using the machine goes down. You begin to accept what you shouldn't accept. Rule segments running long consistently or short, or certain angles or arcs that are always over or under bending, and you kind of compensate for it mentally as you're running. You make the adjustments all the time, but all those times that you spend having to adjust everything, you add that up over the life of how many dies you've made in 6 months, it ends up being a lot of time. It's nice when the part comes off the right length, bent right, and into the board. That's a good feeling, and these machines run at an accuracy of plus or minus 0.02 of an inch when they're kept calibrated. Now the good news is you don't have to calibrate every week. You can calibrate about every other month, depending on usage, and your machine will run very accurately. Now here's something that I see a lot when I'm out and about. I'll meet a guy who's running a bender, and he's really good at pointing and clicking and making that thing go, but the person who was originally trained on how to calibrate the EasyBender, let's say 8 or 9 years ago, may have moved to a different department or is no longer in the country, and so the knowledge has been handed down maybe through 2 or 3 different people to finally this die maker, and there's gaps of knowledge in how to calibrate. They've got some idea, but they're either not doing it regularly enough because they're not confident, or they're missing important segments of the calibration because you need to do it in the right order. So all this to say is we've been selling these machines for so long, 20 years, and there's hundreds of them out there, and then we've got people operating that have maybe 2 or 3 generations removed from the original install. That's the purpose of these videos. So if you're not getting the performance from an automated bender that you think you should, the purpose of these videos is to teach you how to do it, because this video is meant to tell you how important it is. These machines are highly accurate. So let's get ready and let's see if we can get your bender up to the level of production you expect. First thing I want to do is talk to you about our tool blocks. And really, it's part of the calibration awareness. It's not something you have to do every time you calibrate, but I highly recommend you put your tool blocks on a regular maintenance plan. So inside of an S1 here, so whether you've got the new NS2 that has the split blocks or whatever EasyBender you have, they've got a tool block of some type. And in this original here, whether it's the Classic, the Turbo, the S1, you're going to find this tool block right here. Let me give you just some general rules, guidelines for how to keep these things calibrated. About every 3 months, depending on usage, this may need to be sharpened, and you can send it to SDS. We've got a dedicated sharpening department that knows how to sharpen these. And the tendency is people want to just wait until they can't hardly punch anymore before they send them in to be sharpened. They think they're saving money, and that's not true. You run some risks when you allow these male punching tools to get dull, and you can hear it. It punches really loud. The risk is if it's having to work to punch, you're risking actually cracking the male tool. Then you have to pay to have that whole tool replaced, and it's far more expensive. And also, when you keep these tool blocks sharpened regularly, you're actually extending the overall life of the tool block, and these cost thousands of dollars to replace. So by sharpening more frequently, you're going to get actually more sharpenings out of the block and greater longevity with regular sharpening. Then there's just the die itself. You're going to have better joints when you're doing a kiss cut die or a die where you've got to have just perfect joints. A sharpened block on a miter or a straight cut's always going to give you a better joint. So that's my pep talk on tool blocks and why it's really important to keep them sharpened regularly. Now, I understand not everybody may have a backup block, and we can always expedite a tool block sharpening when needed. Well, that's it for now. We'll move on to the next in the series. Okay, the very first step in calibrating an EasyBender is length calibration. It's by far kind of the foundation. What good is a die if it bends correctly and you go to put it in the board and it's long, or there's it's short to the joint. So this machine is very, very accurate, plus or minus 0.005 of an inch on the overall length. And this is the foundation of how that's done. Now, on my computer here, I've got a PDF of our training manual. If you don't have one of these PDFs, just email us, let us know. We'll get one over to you. You may also have a hard copy that you found laying around. But right here in section 1.1, it starts out with length calibration. And you'll notice in the manual, and it says right here in big bold letters, length calibration is very important and should be done before doing any other calibration. It's a pretty simple process. What I've done here, and this rectangle that's up on the screen right here, if you don't have a rectangle that your CAD department's given you, you can draw one, and it gives you step-by-step instructions right here on how to do it. I did it really fast and got it up on the screen. And what we want is a 100 millimeter line. That's what we're after. We're going to get a line segment on your screen that's 100 millimeters long, and we're going to run that piece and then measure that, what the machine gives us against, what it thinks it gave us against what it actually does. So here's the sequence. We've already got the box up there, and you're just going to go ahead and run it like you would any part. You're going to go ahead and select your beginning and the end of your line segment and get your dialog box up that you're very familiar with when you're running a die. You want to make sure you're straight cut, no miters, because obviously the miter tip would get in the way. And very important, make sure right here you're not adding or subtracting any rule to the end of your cuts, so that it's 0, 0 on there. No problem. Go ahead and tell it that looks good. We're going to run it. And here we go. The machine is producing that part. Now what you want to do is take the part that is supposed to be 100 millimeters now and measure it. You want to get a pair of digital calipers, and we're going to go ahead and see what it gave us. Taking those digital calipers, we're going to go ahead and measure that. And it did not give us a piece 100 millimeters. Now, I went ahead and told it not to. I intentionally set it, so it would be wrong, so I can show you how to fix it. So in this case, it is wrong. It is 95.96 millimeters, when it was supposed to be 100. So what do you do when you find that it's this way? You keep that measurement right there, because we need to know that. 99, I lost it. You can write it down. 95.96. What you do next is go right over here to the configuration icon, which is at the top of the screen right here, the little wrench, and you click on that, and you get your configuration dialog box to pop up. jump over to parameter 2, tab 2, and you want to enter in the password right here, SDS, Sam, David, Sam, SDS into the keyboard, hit enter, and then go back to tab 1 right here. And what you're looking for is right here in this section on the left side, calibration pulse window right here. You want to go ahead and highlight over that and enter 100 because we're using a 100 millimeter piece. And then in this dialog box right here, we're going to enter in what it actually gave us. So it gave us, as we had already seen previously, 95.95. So 95.95. So after you've done that and you've got the amount entered in that it gave you, you just jump down here to the bottom right-hand corner of the screen and hit apply. And then after you hit apply, then you go right next door and hit OK. And there it is. So it's taken what it thinks should be the correction. We just run it again and see what did it give us. So in this case, we're going to go over here and run it again. All right, it's closer, but it's not exactly right. So I'm going to go through the sequence one more time to get it to zero in and get that right where it needs to be. Okay, so here we go. We're going to do it again. I'll just talk it out loud real quick. Go to the configuration, go to tab 2, enter the password SDS, hit enter, go back to parameter 1, go down to pulse calibration, put in 100 because that's the piece it should have given us, go down to the window just below, right next to the run, and put in the amount, which was 100, in this case, 19 is what it gave us. And I'm going to hit apply in the bottom right-hand corner, hit OK, and there. Now we'll go ahead and run this again and see what it gives us. Okay, here we go. Moment of truth. And get that in there, and there it is. 100 millimeters. Spot on. This machine is accurate within plus or minus 5/1000ths of an inch. Of course, we're dealing in millimeters here, but there it is. It's spot on, and that's how accurate these machines are. Well, there it is. That's it. That's how you do length calibration. Not too painful at all. Pretty simple and very important. So let's move on to the next sequence in calibration. All right, welcome to section 1.2, nozzle guide calibration. Nozzle guide calibration. Now, the reason we do nozzle guide calibration is it all has to do with that nozzle at the end. What the nozzle guide calibration is all about is right here, the end of the nozzle over time is going to get wear on one side or the other. And if that wear that happens over time is going to affect the distance, let me open up the lid here for you, the distance over to that miter station. Let me get something to point with right here. To right here, that last tool, which is the miter, the distance between that tool and the edge of the nozzle right here, that distance right there will change over time. And because these machines are so accurate, we want to calibrate to that distance, because if that's off, you're going to have one leg of a bent shape shorter than the other leg as you're bending around, so we can calibrate for wear and that distance. Also, if this block is not put in snug, if it's shifted over, that can change that as well. So anytime you insert and reinstall a tool block, you want to make sure that you're all the way over against the rule channel so that this distance stays consistent. Now in this case, we want to calibrate for any potential wear. All right, so let's just throw this all back together real quick, and we're going to run a piece of bent rule so that we can do, let me grab my other computer here. It's got my calibration manual on there. Get that opened up, and it'll give us our step-by-step directions. Okay, so what we want to do is, and in the manual, it again tells you exactly how you can draw this square, and what we want this square to be is 30 millimeters by 30 millimeter legs all the way around from here to here to here, equal on all sides. So we're going to go ahead, and what we want to do is we want to run a segment from here around this direction, and that's very important, that you start here, going this direction, going around and ending here. You're not doing anything with this line segment. So here we go. We're going to go ahead and tell it to start our path here, going down to here, ending our line there. We'll get our dialog box, making sure we're straight cut, nothing here and here on length, adding or subtracting. And we're going to go ahead and we're going to run the piece. And it's going to bend that shape for us. Paying attention to how it ran through the machine as it came through, this would have been the first piece off right here. This would have been the last piece out. And that's important. When we go over here, we'll get the camera to pan over here to our screen right here. You can see I'm going to hold it up to the, and you can see we started here, we came around and we ended there. That's how it came out of the machine. So this leg, according to the manual, is section A, leg A. This is B and this is C. A, B, and C. Now that matters because as you read the manual, it's going to talk to you about legs A and C. B doesn't really have any concern to us, but A and C do. All right, now that we've got the piece run, all we want to do is go back to our configuration, just like we did before when we ran the length calibration. It's the little wrench right there. Get that to pop up. You got to go through the same sequence every time. You got to open up the software. You got to go to parameter 2 right there. Go down to the password, SDS, enter, go back to parameter 1, and we get the screen open. And right here in the configuration window, right here in this little section is the nozzle guide, left and right. So you've got these 4 dialog boxes right here inside of nozzle guide, and we're going to go ahead and get started inputting some measurements into these windows. Okay, so what we want to do is take leg A and we want to measure that first. And you take the back of the rule here, you put it into your caliper, and you just dial that over. We want to hold that tight right there, and we want to see what that leg A measures out to be. And it measures out to be 30.43. So I'm going to write that down. 30.43. And I'm going to go ahead and I'm going to enter that value. I'm going to go ahead and enter that value right here into this section. The right on that window right there. Let me get out of the way so my fat finger's not in the way. Right here. You're going to enter in what it gave you, and that was 30.43. Now what I want to do is go ahead and measure the other leg. I'm going to take this same pattern of taking the calipers, and I'm going to hold it against there, and I'm going to measure leg C, and that came out at 30.28. So I'm going to take that and I'm going to enter that into the dialog box right below where we just were. So I should have wrote it down. See, got to write those things down. 30.28, 30.28, and there it is. And then all I have to do is go down here and hit apply, and it applies it, and it adjusts the numbers right here.
Yes.
The last thing you have to do is after you've hit apply, you need to come up here and check these 2 boxes, and you need to manually change the data underneath whatever's in the word left, right here, the numbers under left, must match whatever is on the right, and it doesn't. So what I'm going to do is I'm just going to go in here and I'm going to highlight whatever's on the left, and I'm going to manually type in whatever's on the right. In this case, that would be 253.935. So we've got that first segment done. We're going to rerun it and see how close did we get. So we know we've already got it all plotted out, so we're just going to go ahead and run the same piece again and see what we get. Okay. Again, remembering which piece came out first, right here, that's leg A. And If we're spot on, they're going to be the same, that distance right there, those two legs. This one's 30.33. Moment of truth, flip it over, do the last leg out, leg C. That's 30.29 compared to 30.32. We can get a little bit better than that, so let's go through the sequence one more time. It's a lot closer than it was, but we can do better. Let's do it again. Okay, so I wrote down the two legs that we just measured. So A was 30.31 and C was 30.35. Now that's really close, but I know I can get closer, just a little bit closer. So we're going to go ahead and follow the same pattern again, and repetition's always good. I neglected to give you one important tip, that when you're measuring these, by the way, you want to measure up as close to the cut bevel as possible. You don't want to measure down at the bottom of the rule when you're measuring these down here, because in some of your tool blocks out there, there's a slight taper going, I'll over-exaggerate, going this way. So it may not be an exactly straight cut, and that's by design. So if you're going to get this right, you want to be measuring at the top of the bevel on A and the top of the bevel on C. All right, so let's go ahead and let's go back in to our configuration. Go to parameter 2. Let's get our password back in there, SDS, enter. We're going to hit back to parameter 1, and there we are back to our nozzle guide, left and right. We're going to go ahead and go over to the right side, and we're going to put in what A was, and A was 30.31. We're going to go down here underneath of it and put in what the value C was, which was 30.35, and we're going to hit apply. Going back up here, again, remember these two values need to match. We need to check that the left value needs to match the right, and it's really close, but it's not quite right. So we're going to go ahead and highlight the left value, and we're going to type in what we see on the right, and in this case, that is 253.955. And go down again and hit apply, and OK, we're done. And we'll check it one more time. All right, remembering how it came off, this is A, this is C. So let's go ahead, measuring up by the top of the bevel, just to make sure that we don't get that taper in the way. Okay, A equals 30.31, and C is 30.31. It's spot on. It's exactly right. Leg A and leg C now match. And this is important, if you can imagine, when you're going to knife a die and you want to put this piece up against another piece of rule, you don't want one leg shorter than the other. This is an accurate machine. Hey, let's move on to our next section. Okay, here we are in section 1.3. This is the center machine origin. Now, the reason we do a center machine origin is there's wear on this tooling. Specifically over here by the nozzle, you've got those bending posts, or we call them fingers, that come up and down next to the nozzle that cause the bender to bend. Now over time, those fingers get worn from tapping the rule. So it affects where the origin or the center of the machine is. So the gear set can wear over time. The nozzle gets a little worn on one side. The fingers can get a little worn. Maybe the left may wear a little differently than the right side if you have the tendency to bend one direction all the time. So you can kind of get everything back on center. Now this is really important to do first before you do your arcs, your radiuses, and your angles. You need to do this bend origin first. Now the ideal way to test the machine origin is to bend a piece of rule 30 degrees to the left and 30 degrees to the right. So here's how we find out how to do that. What we want to do is go over here, right up here to settings, and we want to do that pull down on settings, and then on third one down it says teach, and we're going to hit teach, and there it's going to pull up this field, and you want to look right here. We're after the 30 degree, And right there, we want to write that number down in the pulse column. So 30 degrees pulse, we're going to jot this down, is 17,207. So 17,207. That's the pulse that the machine is currently using in order to produce a 30 degree to the left and the right. Okay, we're going to go ahead and close this down because we don't need it anymore because we got the number that we need. We're going to close that dialog box. Now next, let me jump over here to our book, and it tells us, so what we want to do is go to the manual operation. And where you find manual operation is over on the left-hand side, all the way, second from the bottom, is a little green gear. You want to just tap that green gear right here, and it pulls up this dialog box. So right here, over on this side of the dialog box, is this area called Bend Origin. And what you want to do is just hit Bend Origin, and it's going to ask you if you want to save the origin data. Just tell it yes. Okay, now that we've done the Bend Origin, what we want to do is head right over here next to the other side of this dialog box, and it's got this area that says Test Bend. And just below Test Bend, it says Test Pulse. And this is where we want to enter in that number that we copied down earlier for the 30 degree pressure to the left and the right. So what we do is highlight that, and we enter in that number, 17,000, and your number may be radically different. So don't use my number, use the number that was on your screen, okay? And so you hit that in, you put that in, and then jump down right below it, and it says both. And you hit that icon, both, and it's going to put two pieces out, 30 degrees, one to the left, one to the right. You got to pay attention to which one comes out first. Here's the first one, here's the second one. Now what you want to do is take these two pieces. What I'm going to do is take these two pieces, and I'm going to lay them on top of each other, and then I'm going to pinch them down here and see if there's any gap there, and there is.
I'm sorry, if it's in line with the screen, I can't see
I
it.
can't tell that it's not in line with the screen. So I'm going to step forward.
Yeah.
Okay. All right. I always try to stay in the same spot.
Okay.
Now can you see that?
Yep.
All right, so start over. Ready? Okay, here we go. So here we go. I'm going to take the two pieces, and I'm going to lay them on top of each other, and I'm going to pinch them right here, and I'm going to hold them together and see if it's perfect. They'll be laying flat on top of each other, this side and this side. And look at that, they're not. It's off by that much. That's almost 1/8 of an inch difference right there. You can also see it there. It kind of rocks like a seesaw back and forth. That's not good. That means that it's going to be off left to right, and we can fix this. Let me show you how. Okay, now we're going to do a little bit of math here, and this is about as hard as anything we do in the calibration sequence gets. So what we have to do is take these two pieces that we bent, and what we want to do is we want to find out, it's supposed to be 30 degrees, and clearly it's not because they were off. So we want to take this protractor, and we want to measure what one of the legs was, and that is 25. You may not be able to see that, but it's a 25 degree angle. So I'm going to just jot that down, that angle A equals 25 degrees right there. Angle A equals 25. Then I'm going to take my other angle, and I'm going to measure that. And that is 30. So angle B equals 30. That's currently what I'm getting. Now let's compare that to the sample that's in the manual. And here's the formula. To center adjust pulse, this is the formula. Angle A minus angle B, and then you multiply it by 100. Here's a sample right here using some measurements different than the ones we just got, but let's look at what's in your manual. In this particular case, angle A equaled 33, angle B was 27. So using this formula, 33 minus 27 equals 6. So then you multiply by 100, so 6 times 100 is 600. So in this case, 600 is your new center adjust pulse. you're going to want to make note of that 600. That's the sample here. Let's do ours out of our actual math. And what we know is we want to take angle A, which is 25, minus angle B. So we, of course, know that that is 5. And that times 100, of course, equals 500. So our number, where in the manual here it was 600, in our actual it's 500. So here we're going to go to the next step. Once we've done that math, and I hope that makes sense between this and the book, you're able to see what we're talking about. Of course, we don't need that number anymore. Here's our new math. Okay, so looking at our math, we know that A equaled 25. That was a 25-degree angle, and B equals 30. There was a 30-degree angle. Now, if we look here in our training manual, this is as hard as this will ever get as far as math is concerned. So there's some samples, and I'm going to walk you through the sample in here, and then we're going to look at it compared to what we actually did. But let's look at the sample here. So here's the math formula. The center adjust pulse, and here's the formula, angle A minus angle B times 100. Now you're going, what does that mean? Well, let's look at their example. Angle A, which their first piece out that they measured in this sample would have been 33 degrees. Angle B was 27. So following this math formula, you would take 33 minus 27 would be 6. So again, angle A minus angle B is 6 times 100. The new value 6 times 100 equals 600. And you've got your new number. 600 is your new center adjust pulse. That's what's in the manual. Let's look at that compared to what we just did. So by doing it twice, hopefully it makes sense. So you know that we measured A at 25 and B at 30. So following the math, A minus 30 is actually negative 5. Okay? And then we take negative 5 times 100, and that's going to give us negative 500. And that's our number that we're going to use to do a center adjust pulse. Okay, so now here's what we do. We take this new number we've got, which again in the book, this is called our center adjust pulse. This is where we're going to change it to try to fix that. You go back to the dialog box, it should still be open on your screen, and right over here in bend origin, you've got this number that's showing. And my number, and it'll be different on your screen, my number here is negative 23,000. I need to add negative 500 into the number that's on my screen. Now again, your number is going to be different, but whatever value you got here, you're going to add that number into the value on your screen. So in my case here today, right now, I want to go ahead and increase that number. I'm going to backspace it out, and now my new number is going to be 23,500 because I'm adding negative 500 back in. And there you go. I can go ahead and hit bend origin, and now it's really important. You want to hit save origin data, yes, and it's going to now produce a piece to the left and the right, checking our bend origin. Well, I didn't take you all the way through because after you hit bend origin, you have to actually jump over here and hit both. Tell it to run both. So hit bend origin, like I just told you, and then jump down here and hit both. Now it's going to do one to the left, one to the right. Take those two, and now I'm going to hold them up and see if they're the same. So here we go. It's the moment of truth. I'm going to take my two pieces. I'm going to lay them on top of each other. Now remember, before they rocked, and look at that. They are spot on. No gap at all. They're laying on top of each other perfectly. Either direction. No daylight. Perfect, perfect, perfect. So there it is. The machine is now centered, bending the same from the left to the right. All right, welcome back to the next section in the EasyBender training on how to calibrate. We're coming up to section 1.4. It's called Teach Mode, and in parentheses, arc angle calibration. What that means is we're going to teach the EasyBender how much pressure to apply with those bending fingers when it goes to do a radius, whether it's a 1/4 inch radius or a 5/8 radius or a variety number of angles, sharp bends. We want to teach the machine that, because there's, again, wear on fingers and nozzles, and over time, the machine, we need to calibrate it to get the right pressure. Before we get into that, I want to talk to you about rule data files. That's the first thing you're going to read about when you look at calibration, is understanding rule data files. Now, what a rule data file is, you can imagine that a data file, or data points for pressure, how much pressure to put on 2-point rule, is going to be different than 4-point rule. So just realize that there's a different data file for each type of rule that you're going to use. So that's a clear, simple understanding. Now these files, these data files, have an extension of .el, excuse me, .el, an EL file, you'll hear us call it from time to time. Well, let's jump over here to the machine, and what I want to do is I want to show you how, for example, let's say you've got a machine that's capable of running 2-point, 3-point, 4-point rule, and you want to introduce 4-point rule that's never been put in the machine before. Or possibly you're a shop that runs 2-point, but you've got a soft body rule, and now you want to introduce a hard body rule into the machine. How do you do that? How do you create a new EL file, a new database for new pressure points for a brand new rule type? Let me show you how to do that, and then we're going to get into the specifics of how you calibrate for all of your different databases. So here, let's take a look at this. What you want to do is click right here on the configuration tab with the little wrench, and it's going to pop up the very familiar configuration dialog box right here. And so you're going to go over to parameter 2, and again put in the password we're used to, SDS, enter, and then you go back to parameter 1, and here is the section that contains the information we're going to be working with when we do rule calibration or introducing a new rule EL file. You can see right there, .el. So currently, this tool block A is associated to 2-point rule, and it's using a rule data file of SDS 2-point, and that's just a file that came straight from the factory. So let's say we want to introduce a new type of 2-point rule. Maybe it's a hard body. So what you want to do is make sure that if we're going to introduce a 2-point hard body, that we've got tool block A chosen that's a 2-point block, and it is. So then you'll go down and just close out and go back to here, right here where it says Settings, Teach, third one down, and you'll see that it pulls up this screen, and you'll see there's the 2-point EL file that we currently found in our other dialog box, and there's tool block A. You can't change any of these, it's just verifying that what we saw on the other screen is what has pulled in. But here's how you get a new database. You go right here and click Save As. So you're taking all of the pressure points from this existing file. You do Save As, and now you can rename it and call it, maybe, I'll back this out and just say 2-point, get that over there, and I'll call it hard rule, 2-point hard, and that's just, you can name it whatever you want, but I'll call it 2-point hard.el, and I go okay, and there it is. It's now saved as a 2-point hard EL file, and I can begin to calibrate to this new rule database that I've just introduced. All right, welcome back. We're going to continue on now with teaching the machine about angles and arcs. We just got done looking at how to introduce a new EL file. So here we go. We're off to the races to get started. Here's something familiar that I just got done teaching you. You always want to verify that before you start doing a calibration of angles and arcs, that you really are calibrating to the correct EL file, the correct database. So the way to do that, because nothing more frustrating than going through a whole calibration sequence and you calibrated the wrong EL file. So you want to just go in real quick and verify by doing the configuration, pull it up and make sure that the current file selected is the one you really want to be calibrating to. Don't assume that the last person behind you left it the way you want it. So you'll check that, and if everything looks good, great, you can cancel out. If it's not right, follow the sequence I just showed you to go in and select the right one. Anyway, so now when we're ready to go, we want to go up here and teach it. You're going to come up to the top to Settings. You're going to do the pull-down menu and go to Teach, because now we're going to teach the machine how to do angles and arcs with the adjusted pressure to the EL file, the database that we want to go with. All right, so we're doing settings, pulling down to teach like I just showed you, and you'll pop up this screen. We've got the right EL file named, and here's what you can do. Here's a quick tip. You can right-click with your mouse anywhere in the blue area here, and it's gonna pull up this dialog box. And what you wanna do is just hit Select All, noticing, of course, it's by default started with all of the angles going to the left. And this is what we're gonna do because it's what it opened first. And you just do Select All, and there you can see it put a check mark by all of the various angles from 0.10 all the way to 1.25. Now, you may not want to run that tiniest one and the largest one. You can unselect those and then go ahead over here and you just simply hit Run, and it's going to run all of these in order. Now, it's really important that as they come off, you keep them in order because we're going to measure them with our protractor and input what it actually gave us. So as it runs the sequence, we want to catch them off the machine in the same order. So coming over here, I'm going to hit Run, and they're going to come out down here by the nozzle. You're going to notice that the first few coming out aren't coming out as angles at all. They're coming out as radiuses. And I'll explain why in a moment. But I'm going to go ahead and catch these coming out in the order. And in just a moment, it's going to stop doing this multiple hit. And it's going to give us simple angles. There they come, just one hit angles. Again, I'll explain why it's different in just a minute. Each one is sequentially more than the last because it's adding more pressure, creating what it thinks are the correct angles. And those last bits come off quick, and there they are, all in order, just like it produced. What I've done is I have now laid here on this bench of the EasyBender the parts as they came off, and I told you I'd come back and explain to you why the first 10 pieces off are bent like this in the shape of a radius rather than like the remaining in the shape of just a one bend. The reason being is this first one off is trying to give me a 1 degree angle. And if you could imagine on the protractor here trying to read a 1 degree angle, like I'm going to put it on 1 degree right there, that would be very hard to read. You couldn't really get a reading. So to help us, what it does is, you probably won't show on the camera, but what this is there's 10 sequential hits of 1 degree angle. So 10 hits of a 1 degree angle will actually register. Of course, 1 times 10 is 10. So it's going to read as a 10 degrees because it's giving me 10 hits of 1 degree. So my human eye and my human hands can hold this to get a measurement. Now it follows that pattern for the first 10 pieces off. Once it gets past that, then it goes to single hits. So that's why the beginning looked different than the end. Okay, here we go. I've got the first one off, and it's 0.5 on the angle, and I'm going to hold it up. Now remember, it gave me 10 hits of 0.5, which multiplied by 10 is should read here on my protractor as 5. But actually, I'm looking at it, and I'm holding with my thumb here and allowing the protractor to come down and rest on this leg here without any pressure, and it's reading 3. So what I want to do is go into my screen, and I don't want to enter 3, I want to enter 0.3, because remember now we got to divide by 10, right? 0.3, and I hit enter. And now it will make the automatic calculations to change the pressure the next time I come in and run the sequence again. It automatically took me down to the next piece to measure. So stay right there, don't go anywhere. I'm going to grab the next piece and I'm going to hold it up. I'll show you again, putting pressure with my thumb, letting it come down, and it's 10 hits of 1, so that should read as 10 on here, and it's actually 5. So what I want to go in is tell it, nope, you gave me 0.5 because I divide by 10. There we go. It gets easier as you go on when you get past all this having to do 10 hits and dividing. But I'll go it a couple more times so you just see it. The next one is a 2-degree angle. Hit 10 times should read as 20. And it's reading as 8. So I'm going to go in here and say 0.8. The next one's a 3-degree angle. Should read as 30. It's reading as 13. So that's going to be 1.3. Again, dividing by 10. Next one, a 4-degree angle. It's reading as 20. So that should actually, that'll go in as 0.2. The next one is a 5 degrees. It should read as 50. You get the idea. It's just the same thing over and over again. It reads as 28. So that'll be 2.8. 2.8. This next one's a little tricky. It's 7.5 degree angle. So that should read as 75. And it's reading as 50. So that's going to be divided by 10. It's going to be 5. And we're almost done with these tricky ones. I'll show you how easy the rest of them get. This one here at 10 should read as 100, and it's reading as 74, so that's going to be 7.4. Now we're done with those multiple hits of 10 that we've been dealing with. Now that we're past those sequential hits of 10, we can grab, it's a 1 hit now, and it's 15-degree angle. It knows that's what's next. So this one will be easy to read. It just should be read 15, right? And so I go and I hold it up, and it's actually reading 13. So I go ahead and say, nope, 13. There's no reason to divide by 10 anymore. So then I take the next, it should be 20, and you can see how easy this is from this point. You're just reading what is and telling the machine what it actually gave you. And this time it gave me 18 instead of 20. So you can see it's consistently under pressure. And so it's just teaching the machine that this rule type is a little bit harder. And I'll go to 30, and it's reading as 28. You get the idea. We'll go ahead and pause the camera from here, and I'm going to finish this and bring you guys back in just a minute. All right, I've got my last one in. I've gone through the whole table, and I've entered my last one right there. Hit enter. Then, this is really important, this next step. If you forget this, you're going to lose the good changes you just made. You've got to go right here after you get done entering your last one. Right here at the very top on the left-hand side is, on the right-hand side, it helps if I get my directions correct, is this button at the top, interpolation. You want to go ahead up here and hit that, tell it yes, and then it takes all of what you taught it and it finally dumps it in or applies it to the database. Then the last step, of course, is you hit save right here to save the changes, and then you're ready to move on to the next table. What we've just done is the left angles. Now we need to do the right angles, because one finger may wear differently than the other finger. One side of the nozzle could wear differently than the other side of the nozzle. Requires a different set of pressure. This gives us really good accuracy bending left to right when you take the time to calibrate both sides independent from each other. So to do that, we've got the left done. We simply come right over here and we click on the right angle chart right here. We've moved over and it pops up a very familiar table, just like the last one. We follow the same sequence. Come over anywhere in the blue area, have it pull down this menu, hit select all, uncheck the ones that you don't want, and hit run, and they're all going to come out just like the last time. You don't need to see me do all that again, so I'll come back and show you what I do to go on to the next step in just a little bit. Okay, now that we've done interpolation and we've done the save, we want to do a spot check before we move on to do the angles to the right. We want to spot check the work that we just did. We don't necessarily need to run the entire sequence unless you want to. If your database was way out and you had to bring everything over quite a bit, sometimes it's beneficial just to run everything again and just measure them all a second time. It's kind of up to you. You can do all of them, or you can spot check a few of them. Let's just spot check a few of them. Let's say to spot check, all I want to do is just maybe do the 10 degree, I'll do a 45, and of course 90 is always important. I want to check a 10, a 45, and a 90. I'm just going to run those three. So I've checked them in the box, and I come right over here on the right-hand side, and I hit run. They're going to come off, and I'm going to check them, spot check. If they're not close, it's going to be a hint to me that I probably need to redo the entire table one more time. So here's my three pieces that I asked it to run. Again, 10 degrees, 10 hits. So it should read now as 100, and it's reading as 95, 9.5. It's not quite right. So I'm going to go here and do 9.5 and enter. Tells me I'm pretty close, but not spot on. Now it automatically drops down to the next one because it knows that I asked for it, and it should be 45, and it's exactly 45. So that one's good. You don't do anything with it. You can accept it, and to get it to go down to the next one, you just go down and click it, and go to 90, and read the 90, and it's spot on. It's exactly 90. And so we're good. I do a little adjustment here. This one, but these two are really, really good. So as an operator, you have to decide, is that close enough? Is it good enough for my shop, or do I want to zero in these other ones a little bit better? It's pretty clear that the 45 and the 90 were spot on. It might be recommended at this point, maybe you run everything, those first 10, because they were a little bit off. But again, that's your judgment call to make as you calibrate your machine. Okay, now that we've run through the entire database, we've done interpolation, we've done save, what we want to do is do a spot check on how well did the machine correct itself with what we put in. Now there's a couple ways you can do that. If the machine was way off, and then it could be well advised to go ahead and just run everything a second time. But if you were close and you just kind of want to spot check, you can do that by simply going over here, and rather than selecting all, you can just select the couple of ones you want to do. So in this case, I want to check the 10 degree angle. I'd like to check the 45, so I just go to the box right there next to it, and I just check those, and I think I check the 90. A 45 degree and a 90 are pretty important in the making of a die, and so we're going to go ahead and check those. I'm going to do 10, I'm going to do 45 and 90. I've got them selected, so then I just go over here and I hit run, and the machine's going to only run just those three pieces for me. Now again, the first one's going to be 10 hits because it's small, like I mentioned before. So give me something I can read on the protractor. So there it is, three pieces are off. Keep them in the right order. There they are. So now I'm going to just do my quick spot check and go ahead and hold up the protractor, see what it gave me. It should read as 100, and it reads, man, look at that, 99. So that's close. That's within tolerance right there. So that one's good. This one here, I'm going to go ahead and check the 45, and I'm going to check it, and it's spot on, 45, just like it should be. Check the last one, 90 degrees, see how well it did, and there it is, exactly 90 degrees. Had any of them, if they weren't right, I would have just followed the same pattern as I did before. I'd enter in what it gave me, hit the enter key on the keyboard, it'll jump you down to the next one. And then if you make any changes, every time you make changes, you have to go back and follow the same sequence of hitting interpolation and then save. But in this case, we didn't make any changes. There's no reason to do interpolation and save again. We're ready to move on to the next side. So let's do that. Okay, we're ready to move over and check the angles going to the right. There's one more step we need to do that I failed to mention in the last video, and that is this. Before you move over to do the angles to the right, you want to go ahead while you're still in the left view, go ahead and right-click anywhere in the blue area. It's going to pull up this dialog box. And what we want to do is you want to select the one that says Copy or where it says, I'm sorry, where it says apply angles to arcs. You want to apply angles to arcs. And what this is doing is taking all of the angle pressure we just introduced and you're applying it over to the left arcs. Here's why. These arcs, or these radiuses, are simply sequential pressures of angles in small little bits. So you're taking the good work you've done and you're applying it over, saving time when you get over here to calibrate the radiuses or the arcs to the left. So come down here, like I said, right click, pull up that dialog box and hit or select right here, apply angle to arc. And it says, are you sure? And you tell it yes, and now it's done. Having done that, now we're ready to go ahead and check all of our angles to the right, and you'll find that right here next to the left. You take your mouse, you click on it, it brings up the right angle data. You'll follow the same sequence as previously. You'll go ahead and right click anywhere in the blue area, tell it select all, uncheck the ones you don't want to run, and run them and follow the same sequence as we just did for the angles to the left. All right, welcome back. I've gone ahead and I have calibrated all of my angles to the right, and it looked great. I spot checked, everything looked good. Before I leave this, just like before, I want to go ahead and right click anywhere in the blue. I wanted to apply angles to arcs. So we take all this good data I just did and move it over to the radiuses, to the arcs. I'll tell it apply angle to arc, tell it yes, please do. And now my angles, all my angles are done, both left and right, and I'm ready to move on to arcs. So let's do that. Arcs again being radiuses. Go ahead and click on the next tab over and it'll pull up another dialog box with this database in here. Okay, we've brought the camera in a little bit closer now so you can see what's going on. You see I'm over here on the arc left. We've already done the angle left, angle right. I've clicked here and it brought up this area here, and you can see these are all of the radiuses it wants to produce in millimeters. A 1 millimeter radius, a 10, a 12. We follow the same pattern. We go here and we just right click anywhere in the blue and it'll pull up that dialog box, and what you want to do is tell select all. You want to run all of these radiuses. If you have any radiuses that are greater than 50 millimeters, you don't want to run those because it'd be huge. You're going to have a hard time measuring those. But you go ahead and you've got them all selected, and just like before, you'll come right over here and you'll hit run, and it's going to run all of these radiuses in order, and I'm going to make sure I take them off the machine in the order that it comes off. Okay, here we are. It ran all the radiuses for me. I kept them in the order that they came off of the machine. I'm going to go ahead and set them down right here and get ready to measure them and put into the screen what it actually gave me. So what we do is we just take the first piece off and we measure. Now what we're wanting to do is, if it's got the radius right, it'll be exactly 90 degrees. Whereas before on the angles, you were reading the actual angle it gave you. In this case, when you're doing arcs, you're in this 1, 2, 3, fourth column over where it says 90 degrees all the way down. If it got the radius right, it'll read 90. If it didn't get it right, it'll read either under or over 90. And then you input what it gave you. If it gave you a 93, you put in 93. If it gave you 88, you put in 88. So I'm going to look at the first one and read it, and it's exactly 90. So I don't need to do anything with it. I start out here by clicking it at the top so that it's on the 90. If it looks good, I just hit enter, go on down to the next one and grab it, and let's just see what the next radius should be. It should read 90, and it does not. It's way off, and that's okay. It'll catch it the next time, but it's actually reading 75. So I enter what it gave me, 75, enter. And of course, it's going to apply more pressure the next time we check it. Then go to the next one, and it should read 90, and it reads 91. So it's overbending that radius just a little bit. So I'll enter 91, and it's automatically going to take some pressure off of that one. And you just go through the sequence. It's pretty easy. You just keep going through and just read what it gave you, 93 on this one. And that's what you do. You just keep reading each one all the way down. We're going to go ahead and I'll finish, and I'll have you join me here in just a little bit. Well, there you go. We've done angles to the left and angles to the right. It's pretty simple and straightforward, and you just keep repeating the process. Now, how often should you do this? Well, let me say this. The more often you calibrate, the less time that it takes. If you wait 6 months or 12 months, which I'd never recommend to calibrate your machine, then these pressures are going to be off greater distances, and it takes longer to run and rerun and to check and to double check all of your pieces. If you calibrate once a month or every other month, whatever sequence feels good for your shop based on how much you use your machine, your calibration time is cut way, way down. Your machine will run better, first parts are off, and you'll spend less time actually calibrating. Well, that's it. That's how we teach angles and arcs. Let's move on to the next section. Okay, there we go. I've run through all of my radiuses, all of my arcs to the left. Now, before I jump over to the right, take note of any of these radiuses or arcs that weren't correct, that I had to tell the machine that you were under or over that 90-degree mark. It automatically left them checked because I had to introduce new data. It unchecks the ones that were correct. So what this means is it automatically did the interpolation, so you don't have to do that step anymore. Over on the angles to the left and the right, you needed to do interpolation. When you're over here doing arcs, you don't need to. It's been done automatically for you. So you can see the ones that I need to run again. So in that case, I would just come over here, I would hit run. It'll do those checked pieces. I'll read them for the 90-degree, tell it what it did or didn't do, and just follow that sequence until eventually everything's unchecked. It's exactly where it needs to be. Again, you never have to do the interpolation. It happens automatically. Once you get them all done and there's no more check boxes left, you want to come right over here and hit save to save that work where you are. Now, once the left is done, all the boxes are unchecked, you hit save. I'll go ahead and hit save. And then I come over here and you got to just touch arc to the right. It pulls up the arcs to the right database and you follow the same sequence you did the last time around. So you're just repeating everything. It's pretty simple. Okay, well, there you go. That's how you calibrate the EasyBender on teaching arcs and teaching angles. I want to say regarding how frequently you should do rule calibration. I want to give you kind of a heads up. If you wait too long to do rule calibration, it takes you longer to go through a calibration sequence. I'll go into a die shop and it'll be 6 months or a year since they calibrated. Well, it's going to take a long time to do that calibration because those arcs and angles are going to be so far off and you've got to check and recheck to get it over. My encouragement is calibrate often so that your calibration time can get down to 20 minutes or less rather than an hour and a half. So anyway, we'll move on to the next part in the sequence. Okay, welcome back. We are almost done. We have 2 more sequences to go through. This next section is in 1.5, elongation constant. The elongation constant is just that. Think of something being elongated or stretched. And so as you are stretching 2-point, 3-point, 4-point rule around a sharp bend, it's going to stretch differently. Think of the molecules of the rule getting formed differently and giving resistance, less resistance, or more resistance. Well, we need to calibrate for that, especially a very sharp 45 or a 80-degree angle is going to be different than a 22-degree angle in how it stretches across. So we want to give a calibration for that. The way you do that is you need to burn a board on a laser. We've given you a file to do this test with. If you'll go to your local hard drive and click on that, look for the EasyB folder. So that's EasyB like boy. Open the EasyB folder, and inside there, you're going to see a folder called DAT, D-A-T, data. Just think of data, D-A-T. Open the data folder, and right there, you're going to see a file called testbend. Go ahead and open that file on your EasyBender, and I've already got that right here. Here's the testbend file for doing elongation constant. And as I mentioned already, you want to have this laser burned. Now, when you laser burn this, I just say it because it's important. Your laser needs to have a good quality kerf. You want to make sure your laser's tuned up too. Make sure that the kerf is perpendicular, that it's not bent. Oh, not bent. You don't bend a kerf. You know what I'm trying to say. That you got a good laser burn board. Because if it's not right, it's going to affect your test results when you get to the EasyBender. Now that I showed you where the file is on the C drive, it's as simple as opening it up into your EasyBender software. And of course, you've already had this laser burned. It's really important that whatever laser it's burned on, that laser's tuned up, that you've got a good quality kerf. You don't have a kerf coming in at an angle that's not being blown out at the bottom or too tight at the top, because that'll affect the test results coming here. So a good quality burn board is really important for this test. So you'll go ahead and get this file up, and you'll want to run these pieces, and I'll take you through the mathematical computations of what to do after you've run these pieces and what to do when you get them inserted in the die board. Okay, so now that you've got your burn board done and you've run these pieces off of the bender, you want to go ahead and insert the 90 degree into the die board first. Now when you are running this, you also want to run these end pieces. And when you run these, you want to run where these short pieces here are straight cuts on the end, but when you run these internal pieces, you want to do it miter. You're going to be mitering these pieces on to these side pieces all the way down. So that's important to do that. Now here inside of the manual, the PDF, we're in the elongation constant section, and you'll notice right down here it says, before doing angle elongation, be certain you have properly performed length calibration. Of course, which we already did. That was the first sequence we did. It's very important that this not be done unless you've got an accurate length calibration, or you'll be chasing your tail all of the time. Once you have that 90 degree piece in, what you want to do is you want to check to see if there's any gap between the end of the rule, the miter piece, and that little tiny piece. Said another way, we're looking to see, is that miter running long or is that miter running short? Is the body of the rule pushing in or is it pulled away? If it's pulled away, there's going to be a gap there where you don't have a good, where it's not mitering on properly. If it's too long, it's pushing those pieces out. That stretching is either being overcompensated or undercompensated for, and this is where we can make some small adjustments to whether or not it's running long or short on the miter. And we're checking the 90 degree piece first. What I want to show you now is have the camera come over, and we're going to look at the PDF of our training manual, and I want to go over the mathematics with you of how to compensate if it's running short or if it's running long. So we find that here by scrolling down, and you'll see this is taking us through the sequence of how to open the file, where to find it. And again, as I'd already mentioned, you start with the 90 degree, create that rule path. And it's very important, as it says in the manual, that when you do create that, you've got no extra rule at the start or the end. It's got to be 0 zeros when you're running it. So you go on down, and then, as I was stating earlier, you're looking for either was it running long or short. So it gives us some examples here. For example, in this one, if the miter is coming up short, you subtract the distance that it is short by dividing by 8 the number of bends in the piece. So let's say hypothetically that it was 1 millimeter short. You would want to, and let's go back up, I'm going to scroll back up. Why 8? 8 bends. 1, 2, 3, 4, 5, 6, 7, 8. So since there's 8 bends, it grew, or was short in this case, consistently over each one. So we want to divide that into 8. So if we're 1 millimeter off, we divide by 8, which would be 1.25. So then you go down. If the current value, and that current value is found here under the 90 degree column, I'll show you in a minute on the computer screen on the bender in a second, so it'll be a little bit bigger for you to see. So for example, if the current value is 0.4 in the 90 degree column right here, if the current value is 0.4, then you're going to take what we got from here earlier, you're going to take 1.25 away from the 0.4, so the new value would be 0.25. 0.275. You would take that 0.275 and you would change that in both the left and the right side of the 90 degree, and then run the piece again and verify by putting it in the die board. Pull out the old one, insert the new one, and it should be much closer, spot on. If it's not, you'll just make those same mathematical computations a second time. Okay, I told you I'd show you where it is on a bigger screen on the bender, because it's kind of hard to see on the PDF. In order to get to the elongation area, you click on the configuration, the little wrench. It'll pop this up. This looks very familiar because this is where the parameter 1 and 2 is we've been using throughout the calibration sequence. You go to parameter 2, enter the password, SDS, but now it's right here. It's the next tab to the right, angle arc elongation. Clicking on that, you'll see this is what we were looking at in such a tiny way on the screen over there. You can see the 90 right here. This is where you would put in the new mathematical figures here. Now, once you do the 90 first, you'd go in and you'd do the next one, the 22.5, the 45, the ones that are left on the board, following the same sequence and the same math that I showed you on the 90 degree. When you get all of that in, of course, you'll hit apply and then OK, and you've done elongation constant. Okay, that's elongation constant. I didn't have a burn board here to show you because I'm not in a die shop. If you need questions answered on this because it wasn't clear, just reach out to us and let us know. We'd be glad to follow up with you. Okay, we got one more calibration to do, and then I want to talk to you about file management, and I think we'll be pretty well done. Let's move on to the next sequence. All right, well, welcome to the end. We've got two more things to cover. I want to do section 1.6 and really just have a talk about burr compensation. And rather than walk you through line by line on burr compensation, I'm going to refer you to the manual. However, I just want to talk about it, why burr compensation is important. In the folding carton industry, for example, if you're running a series of pie locks where you've got a short bend at the end of the rule and you go to run 20 of them, you may notice that by the time you get to the 15th, 16th, 17th piece, the end of your pie lock is really short, if maybe not that last little leg is gone altogether. It started out right, but it kind of vanished as you got to the end. What that's an indication of is that the burr compensation needs to be adjusted. As a tool block gets more and more wear on it, the burr gets larger on that piece of rule. You won't notice it if you're doing a one-off and into the board, but you will notice that it will happen as you're doing a small piece sequentially all in a row, like I was just describing 20 pie locks. So you can compensate for this growth in burr compensation by following the procedures that are in the burr compensation section. It's pretty easy, it's not that hard, and just refer to that section of the manual. If you need further help or if it's not clear, just reach out to us and let us know. I mainly wanted to communicate what it is and how it's important. The burr compensation calibration will only work if your feed motor is in good shape, your encoder is working properly, we don't have any issues in the mechanics of the machine where it is misfeeding due to worn parts. So you want to make sure that the machine is tuned up and has no slippage in any of the feeding mechanisms of the older machines. If you have any of those factors going on, you can in the manual, there's recommendations for settings for new blocks, medium worn blocks, and older blocks that have greater burr compensation. You can refer to the manual and how to get closer into the neighborhood where you feel like you need to be. All right, well, that's all I've got right now for burr compensation. We've got one more thing to discuss in the next section, and that's called file management. We'll see you in a minute. Okay, well, welcome to the last video. I want to talk to you just about file management. You went to all this effort to keep your machine calibrated, and what we want to do is create a backup of what you've just done. If anything could happen to a computer at any time. And so we always want to make sure you've got the most recent calibrations, backed up somewhere. What you don't want to do is have this machine calibrated, but you've got a backup that's 4 years old, and that can be really frustrating when you go get a 4-year-old backup and your rule data is like way out of whack, and you'll spend a lot of time trying to get everything back in line. So here's some good practice. What you want to do is simply just go to the C drive of your local computer, and when you open your C drive, there you're going to see a folder called EasyB. So that's easy, like EasyBender, and then the letter B, EasyB. And what we want you to do is make a copy of the EasyB. You can just simply come right here and go copy, and then paste it into the same C drive. It'll say, hey, a copy already exists. Do you want to rename it? You'll say yes, and it'll usually give you an EasyB1. Also, some customers, it's a good idea to do your backup according to the tool block that you're using. So you've got a backup that matches the tool block. Different policies and different procedures for different companies depending on your usage. No matter what you do, make sure you've got a copy of your data files. Also, I'd highly recommend that you work with your local IT department if you've got one in-house so that they're aware of where your EasyB backups are. If you're keeping it only on your C drive, locally it could be at risk of being lost if something happened to the computer that's inside the EasyBender. It's always a good idea to have a data file away from the system in a cloud or on another computer or on a thumb drive somewhere. So that's it. I have surely not given you everything you need to know about calibrating an EasyBender. There's some advanced things, but we've covered the basics. And if you'll do these on a regular basis, you'll love your machine. It'll be spot on. First pieces off into the die board a lot more often. You know, we've had these machines out for over 20 years. They're great machines. We've got lots of new models that are coming out all the time, so stay tuned for improvements. It was good to spend this time with you.